Hi, dear friends, welcome back to Aeroplanes and Boats by Sharath. The basics of aircraft engineering. First of all, we need to understand the main elements that compose an aircraft. First, the fuselage is the central body of the aircraft, and of course, it will be used to accommodate the crew and the payload. So basically, all of the cargo will go into the fuselage. Also, the fuselage is the main structure which attaches the rest of the components of the aircraft. In other words, the fuselage is the key component of the structure of the aircraft, meaning that the aerodynamic forces acting on the wings will be transmitted to the fuselage to some extent. Therefore, the design of the attachment between the wings and the fuselage, or the tail and the fuselage, for instance, are important considerations to take into account in terms of the structure. The higher the demanding loads appearing on the wings for larger aircraft, for instance, the more relevant such attachments will be from a structural point of view. So, the fuselage must also be designed considering two opposing parameters: aerodynamic, geometry, and volume. A small, narrow fuselage would be better aerodynamically because there would be less air resistance, less drag. However, we also need to take into account the volume, right? So if we intend to transport people and payload inside, it has to be reasonably big. So we must find a balance, a trade-off between aerodynamic geometry and volume. The wings, on the other hand, provide lift to the aircraft, meaning that they can provide an upward force which is able to counteract the weight of the aircraft. So the wings are capable to generate lift with the aerodynamic cross-section, which is called the airfoil. In a nutshell, the airfoil geometry, which is the cross-section of the wing, must be optimal in order to obtain as much lift as possible, considering the different velocities and conditions at which this aircraft would operate, while also reducing the drag impact of the wing. In other words, design a wing that maximizes lift and minimizes drag. Of course, minimizing drag is also important in the design of all other components of the aircraft. If, say, we are not able to reduce the drag to the minimum, really, the additional drag of the aircraft will result in what more structural demands, more structural components needed, which employs more mass of the aircraft and more thrust, which means also that we would need a bigger engine to get the aircraft moving. So drag, we must always minimize. So in the end, a lot of attention is put into optimizing the geometry of the wing, particularly in order to optimize the ratio between lift, the upward force, and drag. Another important element, of course, of an aircraft is the tail, which is known commonly also as an empennage, which is designed to provide stability to the plane. Tails are composed of vertical and horizontal surfaces which will stabilize the aircraft. And by surfaces, I mean not only really the tail itself, but also the surfaces that can be moved by demand of the pilot. The tail stabilizes the aircraft for all rotations possible, which would be your roll and pitch. So the tail again, what does it do? It provides stability to the plane. There's a lot of configurations which may be of interest to the selection of such tables, does not only depend on aerodynamic considerations, but also on materials, manufacturing, stability considerations, and more. So as you can see in engineering, there's always probably quite a lot of options, and one must select, considering a trade-off of variables. In terms of propulsion engines, what we commonly have are engines which will take air from the exterior, and this is the air which is present on the surroundings of the aircraft. It will be at air at a certain velocity, which will be the velocity of the airplane. And so this air will go into the engine and it will burn with a mixture of different fuels. The idea is that we transmit the air, this energy coming from the air, into rotational motion of the components of the engine. And by doing this, we will be able to generate thrust. There are several types of jet engines, including turbofan, turbojets, turboprop, and their selection will depend on the conditions required for the aircraft being designed. So jet engines use Newton's third law to accelerate the aircraft, which means that the higher velocity of ejection of the engine, the more thrust it will be able to generate. Also, the more air is ejected, the more thrust it will generate.